have been discussing polynomials and what their graphs look like. We've discussed whether they're even or odd, what degree they are, if their leading coefficient is positive or negative, and where their zeros are located, otherwise known as their x-intercepts. Okay, every graph we've looked at so far is a graph that crosses. See how like when it hits -2, it literally crosses through it? Like it comes up from -infinity and crosses through -2. And then it goes up a little before coming back down and crossing through -1. And then it goes down a little and comes back up and crosses through +1. And then it goes up and then turns and comes back down and crosses through +2. So how many x-intercepts does it have? 4, which makes it degree 4. Now, we know that our degree needs to be an even number because this is an even graph. How do you know that it's an even graph? Right, your ends are behaving the same way. They're both going down, so since they're the same and they're down, it's even negative. So when we get ready to write the equation for this in factored form, we need to go ahead and put a negative in the front because it's negative. Now, our first x-intercept was a -2. How do you represent a -2 in factored form? Our second x-intercept was at -1. How do we represent that? Then our third one was at +1. How do we represent that? And then the fourth one is at +2. How do we represent that? Okay, so that is the equation in factored form. Those are the factors that represent each of these zeros. It's negative because it's going down. It's even because they're both going down. Okay, now what I want you to do is I want you to take that little paper I gave you and fold it hot dog style. Up, and let's look at these three. Starting right here, far left. Is this graph even or odd? Even. Is it even positive or even negative? Positive. Even because they're going the same way, positive because they're both going up. What degree is it?
2.
Right, because we see that it crosses the x-axis 2 times. The first time it crosses the x-axis is at -2. The second time is +1. So what factors will represent that? Right. And there's no need for any sign up front because we're dealing with a positive graph. Okay. Next one below it. Is it even or odd? This one is odd because your ends are behaving different. They're going in opposite directions. Now, is it odd positive or odd negative? Odd positive because it's going up on the right. Okay, remember, we read left to right. So as you read from left to right, it's eventually going up. So that's positive. What is the degree? 3. And we know it has to be an odd number degree because we've already established that it's an odd graph. So you can't write odd right here and then write a number like 2 or 4 over there. That doesn't make sense. If you write odd, this has to be an odd number. Okay, we see that it crosses at -2. It crosses at 0. And it crosses at +1. What factor would I write for the 0 at -2? X plus 2. What factor do I write when I have a 0 at 0? Just an X. And then what? And then X minus 1. Thank you. Okay, now let's look at the third one. Is it even or odd? Positive or negative? Negative, because from left to right, it's eventually going down forever, so that's odd negative. So before you even forget, go ahead and write a negative down here. Actually, it looks like they put it in for you, doesn't it? Okay, now, what degree is it? 3. Because it crosses the x-axis 3 times. It crosses at -1, 2, 3, 4, 5. It crosses at, and it crosses at, okay? So what factor represents this -5? The -2 and the +3. Okay, so far we haven't learned anything new today. You should already have been able to do all three of those. Okay, this isn't new yet. We've been working on those. Now we're going to move into graphs that have multiplicity. No. So go back to the front of your flip book, and now we're going to talk about graphs that have bounces.
Okay, I already know.
Yeah, bounce.
Okay, so see how right here at 1, the graph just crosses through at 1? Pay attention. But over here at -2, it comes down to -2, but it bounces off of it. That's called a multiplicity of 2. Yeah. Okay, multiplicity, I'll write it out.
Yeah, what's the definition?
The bounce means that it's hitting it multiple times, so it's a multiplicity. Okay, well let's think about this. Is it even or odd?
Odd.
Odd. So doesn't that guarantee that your degree has to be an odd number?
Right.
Well, everything we've learned so far, y'all would have said, okay, it hits here and here, so degree 2. But can you say degree 2 when you just said odd? No. The bounce counts as 2 zeros. So here's one of the 3. We'll see how it bounced off the x-axis. Okay, so if a bounce counts twice, that's 2 of your zeros right there, and then it crosses through right there, making a total of 3. 1, 2, 3. Now, the way that you show that in the equation is, see where it bounces at -2? You would still write that as x plus 2, but since it counts twice, you square it. That's all you do. And then over here, it simply crosses through at +1, so there's no multiplicity with that 0. It's just x minus 1. And then the only other thing we have to do to complete this equation is it's going down on the right, it's negative, so we need to throw in that negative sign in the front. No.
So can we do it in 3 bars?
No.
Do it.
That is not your back of this. Flip to the back. Y'all, calm down. Okay. For this one, is it even or odd? Odd. And it is degree 3. And we know that once we've established that it's odd, your degree has to be an odd number. Okay? So the reason it's 3 is because right here, even though we only see it hit -2, it's bouncing on -2. So that's a multiplicity of 2 at -2. And then it crosses through at +1, so that's your third one. 1, 2, 3. Now it's odd positive, so we're not going to have to worry about a sign in the front. How do we represent this bounce at -2? X plus 2 squared. And then how do we represent a cross through at 1? X minus 1. That's all you do. Yes. Okay. Next problem. Next problem. Is it even or odd? It is even this time. How do you know it's even? They're going the same direction, and since that same direction is up, it makes it even positive. Now, if it's even, you know when you say your degree, it has to be an even number, and it is 4. Let's look at where you get those 4. Pay attention. 1, 2, 3, 4. The bounce counts twice. It's a multiplicity of 2. So, this first 0 is a -2, so we would represent that with an x plus 2. Okay? How would you represent a bounce at 0? X squared. Good.
In front of the...
Okay, you know how we always, when you have a 0 at 0, you just put an x? Well, since it's a bounce, you square it. Because it's counting twice there. Okay, and then we also have one at 1, 2, 3, 4, which is represented with an x minus 4.
Can you only have one bounce in one? You can only have one bounce?
No, you can have more than one. Okay, let's look at the third one. Guys, y'all. Okay, for this one, is it even or odd? Even, because it's going the same directions. They're both going down. Since they're both going down, it's even what, DeAndre? What degree is it? 4. How can you say even and then say 3?
The bounce is in the.
Look, 1, 2, 3, 4. Okay.
So it's gonna be S squared in front, right?
Right. That 0 at 0 that has a bounce is going to be an x squared in the front.
And then it's gonna do
This is at negative 1, 2, 3, 4, 5, 6. So x, and then 1, 2, 3, 4, 5, 6. So x minus 6. Is there anything else we're forgetting? It's negative. Don't forget the negative on the front.
All right, let's go to flat.
Okay, go back to the front.
Get out.
All right.
Now.
Okay, for this one, is this graph even or odd?
Even.
It's even because the end behavior is the same. They're both going up. So that makes it even positive. Now, since it's even, the next type of multiplicity is called flattens out. It causes a multiplicity of 3. Now, obviously, we've already established that this is an even graph because both sides are going in the same direction and that direction is up, positive. Now, when you say the degree, I would understand why most of you might say a number like 2 because you see it hit there and there. But anytime it flattens out, see how at negative 2 it kind of like flattened out before it left it? That's a multiplicity of 3. So there's 3 right there and there's 1 making it degree 4. Okay, so at negative 2 it flattened out. So you would put x plus 2, but it flattens out there, so that's a multiplicity of 3. You cube it. And then it crosses through at positive 1, so that's just x minus 1. And that's all you do. Now turn to the back. Well, we'll do it again in case people didn't pay attention. Is this even or odd? Even. Is it positive or negative? Positive. What degree is it? 4. And the reason it's 4, even though we only see 2 x-intercepts, is because when it flattens out, it's a multiplicity of 3. So that's 3 of the 4, and that's the other one. So it's the same one we just did. It should be x plus 2 cubed, and then x minus 1. Well, you're going to have work on your packet to do. Okay, now for this one, is it even or odd? It is also even because they are going the same way. They are both going down, which makes it even negative. What degree is it? It is also 4, because right here where it flattens out at negative 2, flatten out is a multiplicity of 3. So there's 3 of the 4, and then there's the 4th one. Where does it flatten out? So that would be x plus 2 cubed, and then it crosses through a positive 4, which is x minus 4, and then don't forget it's negative, so you have to throw a negative out in the front. No more questions. I don't want any more questions. I'm about to do it, and then you can ask if you still don't understand. Okay, for this one, is it even or odd? Even. Is it positive or negative? Positive, because it's even because they go the same way, positive because that way is up. What degree is it?
6.
Okay, let's see. 1,
2,
2,
3.
3,
Yeah.
4, 5, 6.
Check it.
Did everybody see where we found those 6?
2.
It
bounced.
Shh, be quiet. It bounces right here, which is a multiplicity of 2, and it flattens out right here, which is a multiplicity of 3. So 3, 4, 5, 6. Okay, we do notice that there is a bounce at 0, and that's represented by an x squared. And yes, those always go in the front. Then it crosses through at negative 2, which is represented with a x plus 2. And then it flattens out at positive 4, which is represented by x minus 4 cubed. Okay, now I need you to turn in your packet. I feel like it's page 13.